get started. Now, I don't, I've got everybody. Yeah, no, I found this. Intake, a lot of intake 2 missing. It's, yeah, the maths exam tomorrow. It's a pity they're missing their maths class. Yeah, alright, we'll get started. So, now, what we're having a look at. Can we see okay? Yes. Right. What we're having a look at is the circle. Intake 2ers. The intake 1s will tell you I'm not going to tolerate people talking when I'm talking, so be quiet or get out. Simple as that. Okay, the circle. So what we're looking at here is coordinate geometry equation of the circle. So you would have seen already linear, you would have seen quadratic, you would have seen cubic. So what we're having a look at now is equation of a circle. So there's actually 2 ways to represent the equation of a circle. So the first way is you write it in the following. You write the equation as x minus a squared plus y minus b squared equals c squared. Now, this is the way that's preferred, really, because when it's written like this, the representation is quite clear. The center of the circle is the point AB. So whatever numbers you have here, that's the center of the circle. And you could probably have a guess at where this is going. What do you think would represent the radius? C. So for a little example here, if I had this equation, x minus 1 squared plus y plus 6 squared equals, let's say, 100. Where would be the center of that circle? 1 minus 6, very good. And its radius? 10, good, okay. So that's already our first example done. And you know what? I think I'll open up my graphing program. It will be useful with this lesson. So that's literally example 1 done. You're given an equation and you want to say what the center and the radius is.
A and B are coordinates for the center.
Yeah, yeah. And C is the radius. I see Colin used up all the maths energy from his last lesson. That AB quadratic equation looks tough. Right, okay, have we got that one? Yeah. Now, I said there are 2 ways to represent the equation. So the second way to represent the equation is, whoops. Oh, well, you know what, let me draw this one since it just opened. X minus 1 squared plus, what was it, y plus 6 squared equals 100. If I graph this, now I'll have to zoom out, of course. It doesn't quite look like a circle just because of the scale. There we go. So see, makes a circle. Okay. Now the second way to represent a circle is with an equation that looks like this: x squared plus y squared plus ax plus by plus c equals 0. So that's the second way to represent a circle. Now this way is not as useful as the second, as the first representation. And the comparison I can give you is in coordinate geometry you saw there were 2 ways to represent a line. You could represent it like this, or you could represent it like this. And of course this one I prefer because you can easily see what the M and the intercept are. And you know how to convert between the 2. Okay, so you can imagine we may need to convert between the 2 here, which is what we'll have a look at next. Can I scroll down? Yeah, so our second example, we want to, now it's an easy one. We'll take the one we just did. What was it? X minus y, x minus 1 and then plus 6, is it?
Yes.
Equals 100. So let's just write it in the other form. How might you see this on the MCQ? You might see a question like, which one of these is the same circle as this? So you'd have to match it up. It just, well no, this one here is just expand. It's just expand. So you would have x squared minus 2x plus 1 plus y squared plus 12y plus 36 equals 100. So what's that? X squared plus y squared minus 2x plus 12y. And what's that?
37.
What is it? 37.
Oh, sorry.
Did we not include the 1? So that's 37, yeah. But 100, 37 minus 163, is it?
Yeah.
Minus 63 equals 0. No? Is it?
Yeah, yeah.
Is okay? Okay. Now a little bit more difficult, but not that much more difficult, is the opposite direction. So what we'll do is I'll start with this one and we'll try and convert it into the other form. So now we start in the second form and we want to convert it back into the first form. Complete the square, yeah. Yeah, it should be it. I want to make sure I go back to the original here. Can I scroll down? 1 sec, yeah. Got that? Yep. So, there's a couple of ways to do it, whichever you prefer. So, the first thing I'd like to do for these, well, I'd like to group the x's together firstly. Okay? Leave a little bit of a space. Put the y's. Leave a little bit of a space. And bring that 63 to the right, because you're going to need a number on the right. You see what I did there? I brought the 63 to the right and I left a bit of a space with the x's and the y's. Because what I'm going to do next is I'm going to add a number here to make this a perfect square. I'll have to add 1. This is now a perfect square. And here, and if you're not sure where I got the 1 from, it's half the middle number squared. So here, what would I have to add? 36. Now, if I add 37 to the left, then I must add 37 to the right to keep it balanced. What you do to one side, you do to the other. This conveniently becomes x minus 1 squared, and this one here becomes y plus 6 squared, and then 63 plus 37 becomes 100, which is 10 squared. So the circle is center at 1 minus 6 and its radius is 10. Now that wasn't too difficult, and that's actually a common question in the MCQ, which is good. Okay, it's not too bad. So what we'll do now that we have some basic ideas is we'll have a look at some examples. Okay, so I have a couple of easy ones here and then they get harder. So it's not too bad for this lesson. Okay, so next example 4. So you might want to verify, for example, that 3, 4 is on the circle, let's say x squared plus y squared equals 25. Now, it's not really an MCQ question because it means the answer is only true or false. So it's not really. How can we verify here? I think you should remember this. Sub it in, very good, yeah. 9 plus 16, does that equal 25? And the answer is yes. So this point 3, 4 is on the circle somewhere, on the edge of the circle. Is that okay? Yeah. All right. Next example, 5. So let's do another one. I want to know what is the center And what is the radius of this circle? Okay. Now before I do it, I'll just give you 20 seconds to see if you can do it yourself. I think most of you should be able to do this. So give me the center and the radius. Oh, it's flashing at me. Turn the flashlight off. Look.
Oh, it's so sensitive. It's there.
Turn it off.
How can I turn it off from the
Your phone has a power button, doesn't it? It's not one of these nuclear phones that cannot be turned off. Anyways, Amjad, who's texting you all the time? It's not like you have any friends. Indeed, indeed. Okay. Continuing. Do we have the center and the radius here? We have to get it. So the way I see it is, for this piece I'll have to add a 1. For this piece I'll have to add a 4. And I'll take that 4 to the right. And I'll also have to add 5. Yeah. So that's a 9. 9 is 3 squared. X squared minus 2x plus 1. What's that?
X minus 1
Squared. And then y squared minus 4y plus 4.
Y minus 2.
Minus 2 squared. Good. So now that we've completed the square, where's the center?
1 comma 2.
1,
Comma
2. And the radius?
3.
3. And again, like I said, that's, you know, it's a standard enough Charles question. Okay, here's another one I saw on a Charles paper. Again, this lesson isn't too difficult, so I'll let you try for a few seconds first. The question is, what is the area of the circle given by this equation? X squared minus 2x plus y squared minus 6y equals 15.
Just find the c by r squared.
It's even less work than that. If I want the area, what do I need to find first?
Radius.
Just the radius. Yeah, that's all. Yeah. Is it? Are you sure? Trust you? Never. Yeah, but you're also sleepy Chinese, so. This will look bad if it's not 52 pi. Let's find out. Right, so I complete the square here, and what did you get? Did you get x minus 1 squared plus y minus 3 squared equals,
25.
is it 25?
Yeah,
Yeah,
25, which is 5 squared. So the area, what is it? Pi or
Cube.
cube? No, squared. So what? 25 pi.
Yeah.
Yeah. See? Yeah. Told you. Shouldn't. What have we all learned, class? Don't trust anyone. That's what we've learned.
Did you
Okay.
give it in decimals or you
No, usually the answer is as a pi. So like there might be one's answer that's 25 pi, 52 pi, whatever.
apple pie?
Apple pie. They won't make it that easy for you, okay? Right. Right, here's another one for you to try. What is the circumference of x squared plus 2x plus y squared plus 6y equals 15? circumference. Yeah, yeah, yeah. It's the same circle as before.
Yeah.
So all I was really testing is if you remember the formula for
Yeah,
circumference,
yeah.
which is 2
2
pi
pi
r,
r.
and r is 5,
Five.
so that's 10 pi then. That's fine. And again, I've seen that in the exam. I've seen this one in the exam. Okay, now let's go on to harder ones. So you want to almost just do a dotted line here because we start to make it a little bit trickier now. Okay, example 8. Do the circles x squared plus y squared minus 1 equals 0 and x squared minus 4x plus y squared plus 3 equals 0. I want to know if these two circles intersect. So in other words, I want to know, are they like this where they intersect, or maybe they're not, maybe they're disjoint, maybe they don't intersect. Now, I'll show you what to do in 1 or less than 1 minute, but I think it's good for these questions if you at least think about the idea of what you could do to check if they intersect. That's one thing, yeah. Now, the only problem with that is it's quite difficult system to solve. But you're right. You could perhaps find those intersection points.
Can I find the delta and see how
And that's another way too. Yeah, you could look at the delta to see if there's solutions. So you don't even have to go to the trouble of finding solutions. You just need to confirm that there are solutions. But there's another way. Only if you're desperate, as a last way. Yeah.
Oh, it's a linear.
No, they're two quadratic. They're two circles.
If you make them equal to each other.
I know that's what most said. Yeah, and which is fine, but quite long.
Because lots. So they only have one intersection point.
Yeah. So, if you want to know if these circles intersect, there's actually a simple way to do this. So, if they do intersect, then the distance between the centers should be less than the two radii added together. That's obvious now when you see it. The distance between the centers should be less than the two radii. Okay? So what I'll do, I'll give you just again half a minute. I want the centers and radii. So I'll call that circle 1, circle 2. So circle 1 and circle 2, I need the radius and the centers. Well, I think the first one is 0, 0, 1. Because you can actually just write it straight away. If you're looking at the first one, you can just say it's x minus 0 squared plus y minus 0 squared equals 1 squared. So it's kind of clear. The second one, you'll need to do a bit of work.
Which is
We'll confirm that.
Is the y also
I think
0?
so. Yep, this one works out to be 0. Yeah. And what did you get for x? 2, I think that's right. And what did you get for the radius now?
7.
7?
Yeah.
So you got a 4.
Yes. 7.
What did you get for the radius? Do we need to do it? So if I look at this, that's the same as x minus 2 squared plus y minus 0 squared equals,
Negative.
no, it should be equal to a positive, I hope. That's a 4, isn't it? You need a,
You take the 3 and,
Yeah.
and the 4.
Yeah.
That's
Is
a 7.
did I write it down wrong?
No, but it's minus.
No, because minus 3.
Oh, minus 3.
Minus 3. So
That's minus
one.
3 here, isn't it?
Yeah, minus
So it's
1.
And this is,
Yeah, the plus 4.
plus 4.
Plus 4.
So
Yeah,
it's 1.
so 1.
are you sure it's
Yeah.
plus
Yes.
4, not minus 4? Okay.
Plus 4.
Plus
I'm too tired to. I'll trust you.
Because we added 4
Yeah.
on the left side.
Did you?
Yeah.
No,
It's half of
Half
minus
of-
Oh, yeah, no, you're right.
half
Yes,
of
no, it's right,
minus
it's right, it's right. I agree. Okay, so we need to check if the distance between the centres is less than 2, then they must intersect. If the distance between the centres equals 2,
They don't
They don't.
well, they do, but exactly at 1 point. And if the distance between the centres is more than 2, then they definitely don't intersect. So, if you forgot, we calculate the distance using the formula square root, the difference in the x's. So what's the difference between 0 and 2?
2,
2 squared,
0,
4. And the differences between 0 and 0? 0 squared,
0,
0. So this is equal to
2.
2. So do they intersect or not?
Yes.
They
at
do.
1 point.
Not only do they intersect, but we know that they intersect exactly once, because the distance between the centres is equal to exactly 1 plus 1. Okay?
So they intersect at 1?
They intersect at 1 point. We haven't found the point, but we are saying that they intersect at exactly 1 point only.
But if it's halfway, then it's 1.
If it's it would be 1 0.
Oh.
It'd be the midpoint of the two.
Yeah.
Yeah, if it's halfway in between. So you're right. That would be 1 0 if you needed it. If that's fair enough. There could have been an MCU question saying, where is the intersection point between these? I like that enough that I'm going to add that to the worksheet for next year. If my pen doesn't. Yeah, makes sense. Does anyone spare pen?
But that only works if they intersect 1.
Yeah,
Mm.
yeah.
Mm.
Which I think I'll put in plus mo. Remind myself to add in your question. Okay, can I scroll down? What example number are we on now?
8.
Number 8 now? Okay.
Oh,
9 now. That was 8, was
9.
it?
Yeah.
Right, the next one. So, we have 2 circles. And I want the equation of what's called the common chord. Question? You need me to go back? You sure? Okay. So we want the equation of what's called the common chord. The common chord is this line here. The line that passes through the 2 intersection points between the circles. This is called the common chord. The shared chord. I'll give you the 2 circles and we'll see how to find that. So the first circle is x squared minus 2x. Need a bit more space. X squared minus 2x plus y squared minus 4y minus 4 equals 0. And x squared minus 4x plus y squared minus 2y minus 4 equals 0. Now, this might seem a bit tricky because it might seem like what we're saying to do is we first have to figure out these 2 points. True, if we could find these 2 points, then we could get the equation of the line. But there is actually a sneaky way of getting what's called the common chord. If you were to make these equations equal to each other, yeah, the result is the common chord. Now, why is it the common chord? Well, it kind of makes sense that it has to be because it's like we're trying to solve it. However, when we try to solve it, we're left with x and y. So it must be a solution of x and y that must contain these 2 points. So it must be the common chord. So anyways, the quick way to get the common chord is you just make these 2 equations equal.
Are these the coordinates for the points? Or?
No, it can't give you the coordinates, but it'll give you the line.
Oh.
The reason it can't give you the coordinates is because you have 2 unknowns here. You would have to sub it into one of the other circles. Question, yeah?
I think elimination will be better.
What would you eliminate first?
X
Squared and y squared.
No, this is better.
This is,
One is-
yeah, it's the exact same thing as elimination. If you subtract them, you get the same result. Yeah, so like here, I'm doing x squared cancels x squared, which is the same as that. And then minus 2x plus 4x is 2x, you know, and then the y squareds cancel as well. And then what have you got? Minus 4y plus 2y? Minus 2y. And then they cancel as well. And that's equal to 0.
Yeah.
So you get y equal to x. So that's this line here. Right. That wasn't too bad either, was it? Let's have a look at example 10 now.
So what if they ask for points on the common core?
The actual points.
Yeah.
Well, this one is quite nice. And again, do you know, I've already added that as my next question. So you've given me 2 questions. And the second question I predicted before you asked me. So... this one is not so difficult because you would solve. Well, no, yeah. Which one would you solve? First one with what?
Y is equal to X.
With this one, because what you're doing is you're solving the circle, which is this one, with the line, which is this one.
So you get the first point.
It's quite nice because y equals x. So it just means in this equation you have to replace y with x. Yeah. So we'll just make that example 10. So we get x squared minus 2x plus x squared minus 4x minus 4 equals 0. What's that? 2x squared minus 6x minus 4 equals 0. Yeah? What's that now? X squared minus 3x minus 2. That's nice. What is the solution here? Minus 3.
Plus 1.
No, I was saying not 3. Minus 2 plus 1. Oh,
minus 1.
Minus 2 minus 1.
no, it has to be surds. I don't think it has factors. Do. Minus b plus or minus square root b squared minus 4ac. Oh no.
Minus
No, it doesn't.
It's
It's surds. Yeah? It's 3 plus or minus root 17 over 2. Yeah? Is that what you got on the calculator? Yeah? Which means y has to equal 3 plus or minus root 17 over 2 as well. You got that? Let's have a look. What example number are we on now? 11. Okay. 11. Alright, so this one is, again, I think some people can figure it out. I want to know if the point 2, 2 is inside or outside of the circle x squared minus 2x plus y squared minus 4y minus 4 equals 0. So how could we check if it's inside or outside the circle? Substitute? Maybe. Well, substitute. It won't equal 0. Because I'm not saying it's on the circle. I'm saying it's either going to be inside it somewhere or outside. So how can we check that? Mm-mm.
If it's equal to 0, then it's inside the circle.
No. If it's equal to 0, it is on the edge of the circle.
No, if it's like less than 0.
That depends if it's more than or less than 0. Yeah. That's fine. But the way I, again, like to think about it is just look at the distance. Okay, if the distance is more than the radius, it must be outside. If the distance is less than the radius, it must be inside. Yeah? The distance between the center and the point If it's more than the radius, it has to be outside. Yes? Now again, you won't really get this question in the exam unless they say something like, what is the distance between the center and the point? Okay, so let's get the center. What would that be? X minus 1 squared plus y minus 2 squared equals 1, is it? This needs a minus 1, 3 squared, is it? Yeah. Okay, so let's, the center is 1, 2, and we want the distance between 1, 2 and 2, 2. Yes? Alright, so the formula is the difference between the x's. So the difference between 1 and 2 is 1 squared, 1. And the difference between 2 and 2? 0 squared, 0. The distance is 1. The radius is 3. So look, you have a radius of 3, and the distance between the center and the point is 1. So the answer is it must be inside. Okay, can I continue? Can I scroll down? Yeah. Now for number 12, it'll be helpful if you have this formula, which you may or may not have seen before. So imagine we have this line, ax plus by plus c equals 0, and we have this point here, x1, y1. And I want the distance which is perpendicular between the point and the line. They're called the perpendicular distance. There's a formula for it. It's not too difficult. It's ax1 plus by1 plus c over square root a squared plus b squared modulus on the top. Some of you might have seen this before. It just gives us the distance between a point and a line. So using that now, my question is, what is the shortest distance between y equals 3 plus x and the center of this circle, x squared minus 2x plus y squared minus 2y plus 1 equals 0. Right, so my first thing I should do, I'm just going to change this guy here into x minus y plus 3 equals 0. So then I can clearly see that a is 1, b is minus 1, and c is 3. Now my point is the center of the circle. So what should I do next? Well, then I should get the center of the circle. So if you want to try that with me, we want to get the center here. So it would be x minus 1 squared, yes? Plus y minus 1 squared. And then I can stop, because I have enough information. What's the center? 1, 1. So x1 equals 1 and y1 equals 1. So let's calculate the shortest distance now. Modulus ax1 plus by1 plus c over square root 1 squared plus minus 1 squared. They cancel, and modulus of 3 is 3. So 3 over root 2 is what I got here as the answer. Okay. Yeah, I know we're doing a lot of examples. I have 3 more left and then we're finished, okay? Can I scroll down? Right, what example are we on now? 13.
13.
Okay. What is the shortest distance between the line y equals 4 plus x and the circle x squared minus 2x plus y squared minus 2y plus 1 equals 0? Now, that might seem very similar to what we did, but there's one key difference. Can anyone see what's different between this example and the last example?
Different line.
Ah, no. This one's example 13 and the last one's example 12. That's the difference.
Oh, yeah.
Anyone see the difference?
Yeah, you're not looking at the center.
I'm not looking at the center. Now that actually changes it a little bit. And I can help you that with a graph here. What is, did I say the equation of the circle was?
X squared minus 2x
X squared minus 2x
Plus 2, y squared
plus y squared
minus 2y
minus 2y
plus
plus 1 equals 0. Okay, and what was the line? 4
y
plus
equals
x?
4 plus x.
Okay, now I'm going to graph both of these. Graph. Oh, there we go. And then, what was the other one? Graph that one. So, can you see that in the first example we did the distance between the center and the line? Whereas this one, it's the shortest distance between the line and the circle, which would be this distance. Now, can anybody see how we could get this distance?
You can get the stop for the line. And then
Ah, no. Too much work. Something else. Huh? Give me a second.
X plus 3x plus c over x squared plus b.
I'm not sure if that's a sentence, since I don't know if it has a verb. That's an equation, yeah. But what are you thinking of doing? Like, how can we get this distance? What's the idea? No? Anyone see how to get this distance? You're all very bad at imagining.
Get it the center one and then minus the radius.
There we go. Okay, now we're getting the idea. So, if we get the distance from here to here, and then we just minus the radius. Yeah? Yeah, no imagination. No imagination. Right. So let's see, what's that? That's x minus 1 squared plus y minus 1 squared. Is that right? Is it 3 here?
Yeah.
No.
No.
Oh no, sorry.
I need to put a plus 1 here.
And another
Plus.
No, that's actually fine. I could just leave that there and just put the plus 1 here to balance that one. So it's just 1 then.
Yeah. One.
Yeah. Right, so what's
plus 1 after
that one is in the question. I'm going to complete, it's nothing to do to fix it, it's fine. What's the A here? 1. The B?
1.
Is it? It's minus 1 because you have to take it over.
Yeah.
Yeah. The C?
4.
4. Yeah. The X1?
1.
1. The Y1?
1.
1. The radius?
1.
1. So the distance we want would be 1 times 1 plus minus 1 times 1 plus 4 over square root 2 minus 1. Yeah? The radius, yeah? So that's equal to 4 over root 2 minus 1. Now again, if it's an MCQ, you might have to rationalize and simplify this to match it up. Can I scroll down? Last example, but it's done two different ways. What number is this?
15.
What? 14. 14. Okay. So for this last one here, what I have is I want the tangent to x squared minus 2x plus y squared minus 2y minus 23 equals 0 at 1, 1. Okay. Now, what you could do here, let's fix this first. What is it? X minus 1 squared plus y minus 1 squared equals 5 squared. Yeah? So here's my circle. No, that's not right, is it? Sorry, I had the wrong number here. It's at 4, 5, not 1, 1. Okay. So here is 1, 1, and here is the point 4, 5. And I want to get the equation of this tangent. Now the good news is, I already have a point on the line, don't I?
Yes.
So what do I need to find? I just need to find the m. If I got the m here, I'd be finished, practically. So how can I get the m here? True, that's the second way I'm going to do it. And that's the first way I'm going to do it. This line is perpendicular to this line. Can you know the slope of the blue line?
Yes.
You have the 2 points, so you can. So that's 5 minus 1 over 4 minus 1, which is 4 over 3. So this one is minus 3 over 4. And you know the story, y equals minus 3 over 4x plus c. And how do we get the c? Which point? Oh no! No. 4, 5. I'm not going to do that because that's fine, right? But the other way we can do it, now, guys from intake 2, you'll have to do it this way because the second method is in semester 2, which you haven't seen yet. So for the people in intake 1, Mo, you suggested another method here, which is derivative. Okay? So we implicit differentiate this. What do we get? 2x minus 2 plus 2y dy dx minus 2 dy dx equals 0. So you can rearrange that to get dy dx equals minus 2x plus 2 over 2y minus 2. And of course you can cancel the 2's if you like, but you don't even have to. If you sub in what? If you sub in this point, this works out to be minus 3 over 4. So, you know the story, y equals minus 3 over 4x plus c. How do you get the c? You sub in the point and it's the same again. So you have two ways to do this one. Now this one actually is kind of common as well in the MCQ. And I think the reason it's common enough is because there's two ways to do it, and I'm not sure which way the students taking the exam would know how to do it, but a lot of students could do it at least either this way or this way. So it's not really a big deal. We did questions like this in the lesson on implicit derivatives. It's not really a big deal. Okay, so that's fine. So I think we have 2 hours left, don't we? of this revision class, yeah? It's 3, is it? Yeah, so I think I have 2 more topics to do, and then in the last hour, we'll see what the class wants. It'll either be just random questions or a practice test. You already know? Okay. Right, you can take one of these and then you can go, okay? Sucks to be you. Right.
So the C here is 3, right?
Oh, I didn't work it out because it's all...
I got 8.
Right? You subbed in 4, right?
Is it not 7? Is it not 7 or 4?
7.
Minus 4.
Excuse me?
No, C is 8.
Is it 8?
8. I got an 8.
Did you? Okay, then alright, I think one of my... Guys, there's something messed up with the answers at the back. They're not quite matching up, so they might be out of order. But I can fix it up and reprint it anyway, so you can try the questions. Okay. But give me one blank one back.
Why do you multiply? I know lots of something. Yeah, you multiply 3 times 2 by 4. By 4. Yeah, and then it gives
Yeah, but the y is 5.
y.
Oh, come on. What did column do to you guys? Oh, thank you. Is it super short? Okay. Oh yeah, fair enough. That's probably a good idea. She's seen the exam. Yep. So if she's recommending that you do that, that's a good idea. So how we do in other papers, but make sure you can do that one.
Yeah,
She obviously has a reason for it.
I did it all except the last one.
Yeah, you probably don't want to do that in the exam tomorrow.
Is that the same exam?
No, goodness no. It's a different version of it. I don't even remember what version you did.